Okay, today is Unit 6, Day 1. We are going to start our whole month-long journey into significance testing, which is really getting at the heart of what statistics is about. Based on our sample data, what can we conclude about the population? Today we are going to talk about what a confidence interval is and what a confidence level is. So, I don't know if you'll be able to see this. I have this bucket here, and this bucket, it's upside down, whatever, you get the idea. This bucket is filled with, you can kind of peek in and see, a whole portion of purple beads and green beads. And I'm not going to let anybody know what portion of the bucket is purple and what portion is green. The only information that you're going to get is one little sample cup. I took a random sample of beads from that bucket, and this is the information you have. So if you look at your sample, can we make an inference, can we make a guess at what the population proportion would be? So in this case, if I had, out of 20 beads, if I had 7 out of 20, that would be 35%, right? No. Yes, 7 out of 20 is 35%. That would be my p hat, my sample proportion. The population would be all the beads in the bucket. The sample would be the 20 beads that we got to look at. What we're looking for is the parameter, the true proportion of all the beads that are purple. All we have to go off of is the statistic, the 35%. That's what we're going to call our point estimate. That is the best piece of information we have to guess at the true population. So we're probably pretty sure that the true proportion of beads isn't exactly 35%. But it's probably not that far off, right? If the bucket was 90% purple beads, I would expect to see more purple in my sample. If the bucket was only 2% purple beads, it would be really hard to get a sample that was 35% purple. So we're going to put our point estimate in the middle, and then we're going to give ourselves a little bit of wiggle room. That wiggle room in stats is called the margin of error. So we add the margin of error, we subtract the margin of error, and we say, hey, I am pretty confident the true proportion of purple beads in that bucket is somewhere between 25% and 45%. Okay? And we write it like interval notation in Algebra 2. We can use that information then to get us to work backwards and figure out what the point estimate was, right? If the confidence interval went from 0.47 to 0.53, then the point estimate is the middle of that. So the middle would be finding the average 50%. I can say that the margin of error is half the length. Well, the length, it runs from 0.47 to 0.53. That's a length of 0.06. That would be from here until here. So I chop it in half to get one margin of error, in this case 0.03. One group claims the true proportion of purple beads is 0.43. Does your interval support or deny the claim? Well, since 0.43 would be in our interval, it would be supported. Okay? Anything in the interval is plausible. It is equally plausible. We do not say that it's more plausible if it's close to our point estimate and less plausible if it's on the side. It's just a yes or no question. If it's in the interval, it's possible. If it's out of the interval, we don't think it's possible. So definitions, our point estimate is a statistic. Remember, statistics come from samples. And it provides a reasonable estimate about the population parameter if that point estimate comes from a random sample. If you're just polling your friends, are you going to the semi-formal, yes or no? That's not going to be random data. That's going to be biased. It's not a good point estimate. But as long as your point estimate comes from a random sample of data, you're good to go. We use p hat to help us estimate p, the population proportion, and x bar, our sample mean, to help us estimate mu, our population mean. Our confidence interval runs from A to B, and it contains all the possible values of a parameter. Parameter, p or mu. To find the point estimate, we find the middle. To find the margin of error, we find the distance and cut it in half. How do you read a confidence interval? We say we are blank % confident. And we're going to learn how to put a number in there. But something like we are 90% confident that the interval from A to B captures the true proportion of purple beads, captures the true proportion of people who are going to vote Democrat in the next election, captures the true proportion of students who are tardy to school on Mondays, whatever it is that we're measuring. So here's an example. It says a random sample of 100 adults are asked if they pay for monthly subscriptions they don't use, like a magazine, an app, or an online program. Many do, because they've never taken the time to cancel the subscription. A 95% confidence interval for the proportion of adults who pay for subscriptions they don't use is 0.352 to 0.548. So we're going to interpret it. We are 95% confident the interval from 0.352 to 0.548 captures the true proportion of all adults who pay for subscriptions they don't use. The point estimate, then, when we did our sample, we must have gotten 45% in our sample paid for it, which means our margin of error was 0.098. Don't worry about where this 95% came from. We're about to cover that. Okay. Based on this survey, a reporter claims a majority of adults continue to pay for monthly subscriptions they don't use. Does our confidence interval support this? Well, our confidence interval contains a whole lot of values that are less than 50%, but also some that are more than 50%. So we can't really say for sure, because we have both sides of the equation contained in our confidence interval. It's not very definitive. Okay, so what does 95% confidence mean? If you were in class, we would have played with this applet that allows you to create confidence intervals. So in this applet, we're going to set the population proportion to 0.5 and the confidence level to 80 and the sample size to 100. So what is this saying? This is saying that, like, you want to know the proportion of students at UVA that identify as female. Okay, well, they probably know that. That's probably something that people have submitted. So 50% identify as female. The confidence level is 80. We're going to sample groups of 100 students at a time. 100 students at a time. Okay, so then we're going to select sample and create an SRS. I wish I could show you this, but I don't know how to show you two screens without starting over and using a different method. So what you see on your screen is a whole bunch of intervals that look like this. And most of those lines include 50%, but some of them don't. These are all confidence intervals taken from the exact same set of data. So the population proportion is 50%. But we know from doing Unit 5 stuff that sometimes your sample is a little bit high and sometimes your sample is a little bit low. If we learn that 20% of students at Robinson own a pet other than a dog or a cat, that's fact. The whole population, 20% of Robinson owns a pet that is not a dog or a cat. Sometimes when I take a sample of 10 kids, I'll get 2 who own a pet that's not a dog or a cat. But sometimes when I take my sample of 10 kids, I'll only get 1, or I'll get 0, or I'll get 5. It would be very unlikely, though, to take a sample of 10 kids and find that all 10 own a pet that's not a dog or a cat, right? We have sampling variability, but generally those point estimates are relatively close to the true proportion. We're not getting point estimates that are up at 90% or down at 10%. They're all relatively close. And then when we add our margin of error to each side, since we said we are 80% confident, 80% of these lines, of these intervals, capture that 50% value. 80% of my intervals contain the true proportion. If I instead want to have, sorry, I'm reading this as I go. If instead of taking samples of size, nope, this is all the same. We're just doing it again and again and again. Okay, that's why we are 80% confident, because 80% of my intervals depending on the initial sample proportion, 80% of my intervals capture that true proportion. So if I want to be 90% confident or 99% confident, I'm going to have to figure out how to make my intervals more often capture this 50%. That's what we're going to look at. So what happens if you change the confidence level from 80 to 95%? Our margin of error gets wider. Why does it get wider? Because if I want to capture this value, this 50%, more like 90% of the time or 99% of the time, I'm going to stretch these bars out. Think about the Super Bowl is this weekend. If you said, what's the final score going to be? Well, I'm like 10% confident that one of the teams will score between 30 and 32 points. But I'm 99% confident that one of the teams will score between 0 and 50 points. So when you make your margin of error bigger, your confidence level goes up. What happens when we change the sample size? As we get bigger and bigger samples, our margin of error goes down. If I wanted to capture the true proportion of students